For exercise 4.7.4, we're going to take a look at Venn diagrams. Venn diagrams are another way that we can display information given to us. Suppose an experiment has outcomes, black, white, red, orange, yellow, green, blue, and purple, where each outcome has an equal chance of occurring. Think about these different colored balls in a bag, and you're drawing them out. Let event C be green, blue, and purple, and event P be red, yellow, blue. C and P is blue. C or P is green, blue, purple, red, yellow. We're going to draw a Venn diagram representing the situation. So first off, super quick, notice that blue is in both, and that's how we get C and P is blue. And for the or, we take C and P and put them in one set. We still have some colors in the experiment that we're not considering in C and P, so we want to make sure we represent those also in that Venn diagram. A Venn diagram starts out as a rectangle. This is our whole sample space. And then to represent the two different sets, we're going to draw two circles. Label one of them C and the other P. I know that C and P has blue in it, so I'm going to write blue in the middle. C also has green and purple. P has red and yellow. So I write those in the P set. Notice that where C and P overlap, that's the only place where blue shows up. So if I look at this, green, purple, and blue are all together in set C, and blue, red, and yellow are all together in set P. And then let's check these off really quick. Red, yellow, green, blue, purple. There's our C or P, those 5. And then we need to represent the rest of them. So we have black out here, white, and orange. Some notes about a Venn diagram. It does not matter how big your circles are compared to how big your sets are. The size of the circle does not indicate the size of the set. Also, it doesn't matter where you put the objects in your set, as long as they are in the appropriate regions. So black, white, and orange can be anywhere in this outer rectangle. Green and purple can be anywhere inside set C, as long as they're in C and not in the intersection. Similarly with red and yellow being in P. And that's our Venn diagram for our experiment. Here's example 4.7.6. Again, Venn diagrams. 40% of the students at a local college belong to a club. 50% work part-time. 5% of the students work part-time and belong to a club. Draw a Venn diagram showing the relationships. C is the students belong to a club. P is the student works part-time. Here, though, we're given probabilities. 40% of the students belong to a club, 50% work part-time, 5% are in both. So when we're given probabilities like this, we can consider it like we're taking 100 students and splitting those 100 students up among the different groups. We're going to write the probabilities in, but that's one way to think about it. So 5% of the students work part-time and belong to a club. I'm going to put that 5% right here in that intersection. 5% work part-time and belong in a club. Once I have the 5% in the middle, I cannot put 50% here because that's too much. Now I have 55% in my part-time pool, and that can't happen. So I need to take 5% out of that 50% to get 45% that only work part-time. We're doing some kind of double counting again. That's why we have to be really careful with this. And then for the club, 40% of the students belong to a club. But again, I cannot put 40 out here because then I would have 45 in the clubs. And that's not what the problem says. So I need to take out the 5%, and I have 35% just belonging to a club. Now, how many students are neither in a club nor work part-time? Well, if I add up the probabilities I currently have inside the circles, I get 85%. And if I subtract 85% from 100%, I get 15%. So I know that there are 15% outside that do not belong to a club. And with this example, you do have the answers, but let's talk through how the answers are here. So find the probability a student belongs to a club. Well, that's given to us in the problem. 40% of the students belong to a club. The probability a student works part-time, again, given to us in the information, is 50%. The probability a student works part-time and belongs to a club is 5%. Now let's take a look at the fourth part. The probability a student belongs to a club given the student works part-time. So in order to calculate this with our Venn diagram, probability of club and part-time divided by the probability of part-time. Club and part-time is 0.05. Probability of part-time is 0.50. And if we divide 0.05 divided by 0.50, we get 10%, or 0.1. So given the student works part-time, there's a 10% chance he's also in a club. And the last bullet, the probability the student belongs to a club or works part-time. So we take the club, 0.4, add to it part-time, 0.5, and subtract out the double counted overlap to get 0.85. Alternatively, we could count only the club percentage, 0.35, only the part-time percentage, 0.45, and only the overlap, 0.05, and we end up with the same number. In this case, notice we're not double counting the intersection. There's also even another way to do it. If we talk about complements, I've got this 0.15 that are neither. And if I subtract that from 1, I also get 0.85. Lots of different ways to solve the same problem. We just need to make sure that we're using our good methods and our good thinking skills. We're not double counting. And we are taking everything into account, all of our different parts that we're being asked to find. Here's a third example of drawing a Venn diagram. 50% of the workers at a factory work a second job. 25% have a spouse who also works. 5% work a second job and have a spouse who also works. So we draw a Venn diagram to represent this. Here we've got our factory workers. W says works a second job. S is going to be spouse who also works. When I'm doing a Venn diagram with two sets like this, I always start with the intersection. What do they have in common? 5% work a second job and have a spouse who works. Once I have that intersection, then I can find 25% have a spouse who also works. So I need 20 in here because inside set S must add to 25. So the sum together inside of set S must be 0.25. Similarly, for set W, 50% work a second job. I already have 0.05 in there. Since I already have 5% in my working a second job group, I need 45% outside that intersection so that inside the workers, they add up to 50%. And then the last step is what percentage of workers have neither? So if we add up what's inside the Venn diagram already, 0.45 plus 0.05, that's 50%, plus 0.2, 70%. Outside the two circles, we would have 30% that are neither. They neither work a second job nor have a spouse who also works. So hopefully these 3 examples help you through working with Venn diagrams, being able to set them up, and then how to work with probabilities associated with these Venn diagrams.